On this video, I want to go briefly through some common mistakes that I see being made on the homework problems for quantified logic. And so let me give you some examples. I'm going to use the interpretation from the fourth homework assignment. So I've got it here. I'm going to copy it and paste it into a new document here. And one of the things that I notice has to do with how people use quantifiers. So let's take an example. Let's take anyone who is good-hearted is brave. Let's just take a statement and show how you'd symbolize it giving this interpretation. So sometimes I've seen this being symbolized just as, for example, bx arrow, gx arrow bx, with no quantifiers. So sometimes people are leaving out the quantifiers. And this is in violation of a rule that says you can't have any free variables in a statement of quantified logic. So no free variables are allowed. That is, whenever a variable is used, there needs to be a quantifier for that variable. And in this case, anyone who's good-hearted is brave. Anyone, in this case, would be the universal quantifier. So if you put in the universal quantifier for all x, now you can't just write after that quantifier, you don't want to just put if gx then bx, just like that, because what you want to show in the symbolic statement is that the universal quantifier covers the variable that comes after it in the g, but also covers the x over here after the b. And the way you do that, of course, is just like with the negation. The scope of a negation is indicated by using parentheses, except in the case of a single statement letter. If you have a two-place connective, just the same thing works in quantified logic. If you have a two-place connective, you want to show that the scope covers the whole string of symbols. You have to put parentheses around the whole thing, like that. So that's one error, or one set of errors that I find. One, people forget to use quantifiers, and then B, people forget to indicate that the scope of the quantifier is indicated with the parentheses. Then let's look at multiple quantifications. So suppose you have a statement like let's change this interpretation a little bit. Let's just use something a little bit simpler. Let's use a domain of numbers, and let's change these predicate symbols to just be LXY means x is less than y, and GXY means x is greater than y. And let's symbolize the statement: if one number is less than another, then the other number is greater than it. And you can start to see why symbolic logic is useful, because in English it can be hard to keep track of what the different references are of the pronouns. Here we have if one number is less than another, then the other number, well, the other number is the, it refers back to the another number. in the first part of the conditional statement. Here, other goes with an other in the antecedent, and the it at the very end refers to the one number in the antecedent. And actually, something that's kind of cumbersome in English can be easier to express more precisely with the symbolic language, because you have these variables, the x's and y's, that work just like pronouns in English. They work just like it, except because you're using x and y, you always know which of the objects you're talking about is being referred to. There's no question about what the pronoun reference is. So here, without quantifiers, basically you're saying if x is less than y, then y is greater than x. So now when you put the x's and y's in, the x's correspond in the right way and the y's correspond in the right way. And in a math class, you might actually just see an expression like this. If x is less than y, then y is greater than x. But what is implicitly understood, what is unstated, but what is understood, is that we're talking about for any number. There's really a quantifier out here. It's really saying for any x and any y, if x is less than y, then y is greater than x. That's really understood out in front if you saw this in an arithmetic textbook. In the logic class, though, we make the quantifiers very overt. We put them out there in the open. So here's an issue that I've seen come up. Now let's get rid of the English and just use L and G. So if LXY, then GYX, then y is greater than x. Kind of a loglish translation. And then going all the way into the symbols from statement logic, you'd have the LXY on the left, and then you'd have the GXY on the right with the arrow in between them. So let's put that down in that way. There's the LXY, the GYX, and we'll put the arrow in between them. And now you have to have quantifiers out in front. And what I see some people do is they'll put a quantifier out in front. Sometimes I'll just see this for all, but there won't be any variable there. And of course that's not right. There has to be a variable. Whenever you use a quantifier symbol, next to the quantifier there has to be a lowercase letter, X, Y, Z, one of those letters. In this case, you need X and Y. Sometimes I've seen people write for all X, LXY arrow GYX. They'll write something like this. They'll write a universal quantifier, but for just one of the variables. And of course, then you have this Y that doesn't refer to anything. You need something that binds that variable to a quantifier. What this says is any number that is less than it is such that it is greater than x. And I have no way to understand what that means because I don't know what it is talking about. And the way you fix that is by putting in a quantifier that grabs onto that letter y. For all x and for all y, for all x in the domain and all y in the domain, if x is a number less than some number y, then y is a number that's greater than x. And you need to remember, if you have multiple if you have multiple variables, you need multiple quantifiers. And then finally, there's another kind of confusion that I've seen, where I've seen people put individual constants in place of what should be variables. So if in the interpretation, for example, A refers to the number 1 and B refers to the number 2, I've seen some situations where people have just put in constants in place of the variables. And this says for all x and for all y, if 1 is less than 2, then 2 is greater than 1. Which is true, but you're not saying anymore what you were asked to translate into the symbolic language, which is for any numbers x and y, if one's less than 1, then the other is greater than that first one. So you have to remember, you have to plug variables in where variables go, and use the constants only if you're talking about specific objects, only if those are specific names that you're given in the interpretation that you're supposed to be translating into the symbolic language. I've also sometimes seen, for some reason, people seem to put capital letters in place of variables. I don't know what that would mean. I've seen things like this. And so LX capital D would make no sense, both because the variable has no quantifier, and you have a capital D going where there should be an individual symbol. And individual symbols, recall, are lowercase letters. The variables are U, V, W, X, Y, Z, and all the other lowercase letters are individual constants, or we also call them names. They name specific designated objects in the domain. So those are a few things that I've seen to watch out for.